Before we do any calculations in acids and bases, we need to talk about the role of water. If substances are not wet or moist, they cannot be categorized as acids and bases. So first let's just talk about water and what is autoionization of water and related questions to that. If you take two molecules of water, H2O, liquid, pure water, they interact with each other and they partially dissociate. So there is equilibrium. And they will give you a minute amount of hydronium ions and the same quantity of hydroxide ions. Sometimes this reaction, autoionization, is written in terms of one molecule only. H2O liquid dissociating partially, double arrow, and gives you hydrogen ions and gives you hydroxide ions. First thing I want you to realize is that the hydrogen ion and hydronium ions are exactly the same in concepts of acids and bases. Now, if we write equilibrium constant for this dissociation, K equilibrium in terms of concentrations is products over reactants. So it's hydrogen ions times hydroxide ions divided by reactant H2O, but I want you to realize H2O is pure liquid, so we are going to ignore it. Don't put 0. It's already included into the constant. So Kc simply is products only. There is no reactant here, concentrations of them. And since this is dissociation of water, you can just put subscript of W for that instead of Kc is equal to H plus times OH minus. Now when we measure, this constant is equal to 1 times 10 to minus 14, of course at 25 degrees Celsius. It is function of temperature. So Kw is a constant and it's equal to this. What does it mean? It means that concentration of hydrogen is simply equal to concentration of hydroxide, and it's really square root of that number, 1 times 10 to minus 14. If you take the square root of that, it's 1 times 10 to minus 7. Now I want to talk about P scale, pH or POH. P simply is a math scale and it's negative log base 10, not natural logarithm. It's a base 10 logarithm. So once you see P anything, just take negative log of that in calculator and you have answered the questions. For example, pH of pure water at 25 degrees Celsius is negative log of H concentration. And it's negative log of 1 times 10 to minus 7, which happens to be 7. Now same thing with POH. POH is another complementary. For every H that you have in this system, you have equal amount of OH for pure water. And it's negative log of OH minus, and it happens to be 7. Now if you add this to pH plus POH, you always get 14, whether you talk about pure water or acidic solution or basic solution. Of course, at 25 degrees Celsius. Now if there is a substance that you call acid, for its operation, it reacts with metals, for example, it neutralizes bases. Simply, it means you have more hydrogen ions than hydroxide ion. And it means that pH is less than 7. If you call this pure water neutral, which it is, it simply means you have equal quantities of H plus and OH minus, concentration wise, and pH is 7. If you call something basic like sodium hydroxide, that means simply in a moist solution you have H's which are less than hydroxide and pH is bigger than 7. Now this is crucial to remember. These all are true at 25 degrees Celsius. Temperature will change your scale of pH, your value of Kw, and let's see a calculation involving that. So let's go to the next question, sort of a question. Calculate pH of pure water at 40 degrees Celsius given Kw is 2.92 times 10 to minus 14. Now let's just write the equation H2O dissociating partially, giving you H aqueous and OH minus aqueous. Now remember, at 25 degrees Celsius, this was 1.0 times 10 to minus 14 as your Kw. Now in this question, at 40 degrees Celsius, Kw is 2.92 times 10 to minus 14. Before we answer that question, let's just decide if it's endothermic or exothermic. As temperature increases, Kw increases. What does it mean? Where is the quantity of heat? Now let's just go after Le Chatelier principle from our equilibrium plus OH minus. Now as temperature goes up, you're shifting to the right, and H plus and OH minus are going up. So heat is a quantity that is sitting on the reactant side. As temperature goes up, you shift to the right. Therefore, reaction is, I'm going to spell it out rather than RXM. Therefore, this reaction, autoionization of water, is endothermic. Remember this for sake of many questions of IB just by itself. Is autoionization endothermic? They give you KWs. You should be able to compare the two numbers. If temperature goes up and Kc or Kw goes up, you are endothermic. Now let's go after calculations. At 40 degrees Celsius, still H plus multiplied by OH minus is equal to Kw. This time it's equal to 2.92 times 10 to minus 14, a new constant at new temperature, 40 degrees Celsius. What does it mean? It means that H plus is simply equal to OH minus, and it's equal to square root of this new constant, 2.92 times 10 to minus 14. And when you take square root, it's 1.71 times 10 to minus 7. So pH is negative log, P anything is negative log of this number, 1.71 times 10 to minus 7, and it happens to be 6.77. So pH of water, pure water at 40 degrees Celsius. The scale totally changes once you change the temperature. If you go from room temperature, which is our standard temperature that we measure all constants at, you will change the Kw and you will change your scale of pH and pOH. So pH is equal to pOH 6.77 at 40 degrees Celsius.